Salam and hi, I am Amir Sultan Saleh Al-Mklafi with matrix number AE 2004. And today we are going to present the numerical programming, the J10201. The title of MATLAB Simulink for Lab 4 mini project. For our lecture, Dr. DC, and we are from section 1. And our team members are me, Amir Sultan, Muhammad Yashirat, Yatafan, and finally Muhammad Adil. So for the content of our project is 1 introduction to methodology, 3 questions, and 4 manual calculation, 5 results, 6 discussion, 7 and this range is the conclusion. So I will present the introduction and the methodology and a little bit of the result. So for the introduction, MATLAB is a programming environment created especially for science and engineering to analyze and create products and systems that change the world. The MATLAB language is a matrix-based language that enables the most natural expression of computer mathematics. Is the core of the MATLAB. In this project, we use Simulink, and Simulink is a block diagram environment used for system design with multi-domain models, simulation prior to hardware deployment, and deployment without writing a code. For the methodology, using the MATLAB Simulink software, we create an R to R digital to analog converter circuit. Only 2 resistive values are used in the R to R resistive ladder network. For the base resistor R, we use a 10 resistor, which making 2R is a 20 resistor as a result. An R to R resistive ladder network is nothing more than long strings of parallel and series connected resistor acting as interconnected voltage dividers along its length, and whose output voltage depends solely on the interaction of the input voltage with each other. Consider the basics 4-bit R to R ladder network. All the binary input are grounded at 0 volt, which means VA equals VB equals VC equals VD, R equals 0 volt. So for the questions, for questions A, what is R and to R digital to analog converter circuit? The R to R digital to analog converter or DAC is a data converter that converts a digital binary number into an analog output signal proportional to the value of the digital number using 2 precision resistors. For question B, referring to figure 1, which is in the project of the question, discussion on the output voltage calculated by the MATLAB Simulink software with 1 only input VA is high, 2 only input VB is high, 3 only input VC is high, and 4 only input VD is high. So the answers will be followed. For the result for question 1, the output voltage calculated with input VA. So we did a manual calculation for this, and the final answer was 0.625 volt. And we use VA equal to 10,000. So as you see here from after the manual calculation, we made a simulation in Simulink at MATLAB. You see this circuit, and the final answer is 0.625. So we confirmed the answer. And that's all this my part. Thanks for listening.
Assalamualaikum. My name is Muhammad Alif Aiman bin Abdullah. Today I would like to present about the result that we get from the MATLAB Simulink. So this is our circuit. For the number 3, the output voltage calculate with input VC. So this VC equal to 10 volt, and we have 1 2 3 4 5 6 7 8 resistor. After that, this is voltage measurement, and after that we run, so we get 2.5 volt for the result. So this is for the number 4. The output voltage calculate with input VD. So VD is equal to 10 volt. So this question also have 5 resistor, 3 R and 5 2R. So this is voltage measurement, and we run using MATLAB Simulink. We get 5 volt, same as manual calculation that we get. After that, construct a table to show the relation between input voltage and output voltage. So this is the manual calculation. Digital to analog output voltage equation. Vout equal to VA plus 2 VB plus 4 VC plus 8 VD over 16. Generalize R minus 2R DAC equation. So we get Vout equal to VA plus 2 VB plus 4 VC plus 8 VD plus 16 VE plus 22 VF plus ... and etc over 2n. So the next slide is this is the truth table, the digital, and this is the input Vout expression and Vout. We have ABCD and 8 VD plus 4 VC plus 2 VB plus 1 VA over 2 over 4. Use that equation before that I show it, and the Vout is 10 volt. So we use the first binary number 0000. For the Vout expression is 0 times 10 plus 0 times 10 plus 0 times 10 plus 0 times 10 over 16. We get 0 for the Vout. After that, we use digital input binary 1 0 0 0 1. So 0 times 10 plus 0 times 10 plus 0 times 10 plus 1 times 10 over 16, and we get 0.625 volt. After that, digital input is 0 0 1 0 in binary, so 0 times 10 0 times 10 2 times 10 0 times 10 over 16, so we get 1.25 volt. After that, 0 0 1 1 in binary, so we use Vout expression. In Vout expression, 0 times 10 0 times 10 plus 2 times 10 plus 1 times 10 over 16, and we get 1.875 volt. And 0 1 0 0 0 times 10 plus 4 times 10 plus 0 times 10 plus 0 times 10 over 16, and we get 2.5 volt. So that 0 1 0 1 0 times 10 plus 4 times 10 plus 0 times 10 plus 1 of times 10 over 16, and we get 3.125 volt. After that, 0 1 1 0 in binary, 0 times 10 plus 4 times 10 plus 2 times 10 plus 0 times 10 over 16, and we get 3.75 volt. So that 0 1 1 1 0 times 10 plus 4 times 10 plus 2 times 10 plus 1 times 10 over 16, and we get 4.375 volt. And then 1 0 0 0 0 8 times 10 plus 0 times 10 plus 0 times 10 plus 0 times 10 over 16, and we get 5 volt. And 1001 h times 10 plus 0 times 10 plus 0 times 10 plus 1 times 10 over 16, and we get 5.625 volt. 1010 h times 10 plus 0 times 10 plus 2 times 10 plus 0 times 10 over 16, we get 6.25 volt. 1011 h times 10 plus 0 times 10 plus 2 times 10 plus 1 times 10 over 16, and we get 6.875 volt. 1100 digital input, and VR expression is 8 times 10 plus 4 times 10 plus 0 times 10 plus 0 times 10 over 16, and we get 7.5 volt. 1101 8 times 10 plus 4 times 10 plus 0 times 10 plus 1 times 10 over 16, and we get 8.125 volt. 1110 8 times 10 plus 4 times 10 plus 2 times 10 plus 0 times 10 plus divide by 16, so we get 8.75 volt. And 1111 8 times 10 plus 4 times 10 plus 2 times 10 plus 1 times 10 over 16, and we get 9.375 volt. So that's all from my truth table. After that, we go to the next slide. So this is a manual calculation for 1 bit binary code equal to hash GFE DCBA 00000000 and 1 for A. So this is the VOUT equal to VA plus 2VB plus 4VC plus 8VD plus 16VE plus 32VF plus 64VG plus 128VH over 2 power of 8. So equal 1 times 10 plus 2 times 0 plus 4 times 0 plus 8 times 0 plus 16 times 0 plus 32 times 0 plus 64 times 0 plus 128 times 0 over 256. So equal to 0.03906 volt. For the 10-bit binary code is hash GFE DCBA 00000010. So VOUT is 10 plus 2 times 10 plus 4 times 0 plus 8 times 0 plus 16 times 0 plus 32 times 0 plus 64 times 0 plus 128 times 0 over 256 is equal to 0.07813 volt. For the 100-bit binary code equal to hash GFE DCBA 00000100. So the VOUT is equal 1 times 0 plus 2 times 0 plus 4 times 10 plus 8 times 0 plus 16 times 0 plus 32 times 0 plus 64 times 0 plus 128 times 0 over 256. And the result is equal to 0.1563 volt. For the 1000-bit binary code is HGFE DCBA 00001000. VOUT is equal 1 times 0 plus 2 times 0 plus 4 times 0 plus 8 times 10 plus 16 times 10 plus 32 times 0 plus 64 times 0 plus 128 times 0. The total for the 100-bit is 0.1563 volt. For the 1000-bit binary code is equal hash GFE DCBA 00001000. So VOUT is equal 1 times 0 plus 2 times 0 plus 4 times 0 plus 8 times 10 plus 16 times 0 plus 32 times 0 plus 64 times 0 plus 128 times 0 divide by 256, so we get 0.3125 volt. So that's all from me. Thank you.
Okay, my name is Muhammad Ishaq bin Muhammad Radwan. My metric number is CE220041 and I am from group 9. Okay, for the 10,000 bit, the binary code is on the E, should be 1 and the other is 0. And if we do the calculation, so we need to 16 times 10 over 256, and we get the 0.625 volt. 0.625 volt is we out for the 10,000 binary. For the 100,000 binary, we need to times the 32 times 10 over 256, and we get 125 volt, 1.25 volt, and it's we out for 100,000. For the 1 million bit, the V out is 2.5 volt. By calculation, 64 times 10 over 256, and for the 10 million bit, we times 1 to 8 times 10 over 256, and we get 5 volt for V out. 100 million, 10,000, 10 million bit. And this is the circuit for the 1 bit, and from the manual calculation we get 0.03906 volt, and we get the same value in the MATLAB. Then for the 10 bit circuit, we get the values from the MATLAB, and the manual calculation is same, which is 0.07813 for the 100 bit. The V out is 0.1563 volt, same with the manual calculation. And last 1,000 bit, the V out is 0.3125 volt. That's all from me. Thank you.
So, hello, doctor. My name is Yatavan. My metric number is DE210037. So, as my friend mentioned, present and explain about the manual calculation. So, for 10,000 bit, we got 0.625 volt. But for each and every 10,000, 100,000, 1 M and 10 M, we got each is times by 2 volt in the end. For example, for 10,000 bits, we got 0.625. For 100,000 bits, we got 1.25, which is 0.625. It's times by 2, and then we got 1.25. And then for 1 M bit, we got 2.5 volt. And lastly, for the 10 M bit, we got 5 volt, which is respectively every 10 10,000 bit, 100,000 bit, 1 Mbit, and 10 Mbit is times by 2 in the end of the manual calculation. So for the discussion, a 4-bit resistive ladder circuit is utilized to find the proportional output value in relation to the input source. The circuit involves connecting resistors in both parallel and series configuration and then analyzing the circuit to determine the output. The equivalent resistance of three resistors, which is R1, R2, R3 we use in the circuit, can be calculated using the formula Ra equals to R3 plus R1, R2 is parallel. We can see it in the figure just before this. The output voltage can also be calculated using the MATLAB simulating software. The resolution of the resistive ladder network in the deck is determined by the number of digital inputs represented by N. In the formula, V out is V in over 2. When the input voltage is high, the logic level is 1 and the other inputs at a logic level is 0. So for the conclusion, in the end of the lab, the project, we have gained an understanding of the basic principles of MATLAB Simulink. We have been using each and every lab in the numerical programming subject and how to utilize it for a designer and analyzing dynamic system models. Additionally, we have learned how to access blocks function through the Simulink library browser. We have also seen how to create an R to 2R digital to analog converter circuit by calculating the output voltage through the use of the MATLAB Simulink software. Both the calculation method and the use of the MATLAB Simulink software can be used to obtain the same result for the R to R digital to analog converter circuit. Thank you.